From the video, I can see that the tool shows a 3D skeletal animation alongside graphs detailing ankle flexion, knee flexion, and hip flexion, as well as their respective moments. The tool also displays metrics such as speed, cadence, stride length, and stance time. As you can see, the tool transitions between the stance and swing phases, updating the graphs and metrics in real time. Are you finding this visualization helpful for understanding the biomechanics of walking? What specific applications do you envision for this type of tool? Are there other types of data or visualizations you would find useful to include in this tool for analyzing human movement? All right, viewers, let's break down what's happening on the screen in real time. As you can see, we're observing a 3D skeletal animation transitioning between the stance and swing phases of walking. Alongside the animation, we have graphs illustrating the ankle, knee, and hip flexion angles, as well as their respective moments, all changing dynamically. The tool also presents key metrics: speed at 1.2 meters per second, cadence fluctuating around 110 to 120 steps per minute, a consistent stride length of 0.9 meters, and stance time varying between 40% and 60%. Certainly, looking at the current position in stance phase, the skeletal animation shows the leg in contact with the ground. The ankle is at 14.5 degrees. The knee flexion is at 29.5 degrees, and the hip flexion is at 22.6 degrees. The hip moment is at 1.1 Newton meters per kilogram at this moment. Would you like a more detailed look at a particular joint or metric? All right, viewers, let's analyze this new position in the swing phase. The skeletal animation shows the leg is off the ground and moving forward. Here, the ankle is at minus 14.3 degrees, indicating dorsiflexion, the knee flexion is at 66.3 degrees, and the hip flexion is at minus 6.8 degrees. At this point, the hip moment is measured at 1.1 Newton meters per kilogram. And for you viewers, what other tools or features would make this analysis even more insightful or practical for your specific needs? Any thoughts on how we can push the boundaries of biomechanical analysis? Thanks again, viewers. Now at 86% through the swing phase, we see the skeletal animation further extended. The ankle is at minus 11.2 degrees, the knee flexion is at 28.0 degrees, and the hip flexion is at 4.6 degrees. At this point, the hip moment is measured at minus 0.1 Newton meters per kilogram. Are there specific patient populations or movement patterns you believe could benefit most from this detailed gait analysis? We are eager to hear your thoughts and insights. Thank you, and viewers, as mentioned, you can explore this tool firsthand at bionichaos.com/GaitesIMV3. Feel free to experiment with the different features, analyze various positions, and let us know your thoughts and feedback on how we can continue to improve and refine this interactive gait analysis tool. Definitely. For those of you watching, how do you think this tool could be integrated into clinical practice or research settings to improve patient outcomes or advance our understanding of human locomotion? We would love to hear from you. Of course, for those interested in exploring further, the BioniChaos.com website features various interactive simulations. There is a smartphone neck simulation to demonstrate the biomechanical concept of smartphone neck, a signal-savvy age and skin tone simulation to explore the impact of age, skin tone, and LED intensity on PPG signal quality, an advanced peristaltic pump simulation, and PPG Signal Quest, the quality game. Are there any simulations that grab your attention in particular? The advanced peristaltic pump simulator is pretty cool. From a first-person perspective, I can see how it allows users to explore the inner workings of a peristaltic pump. You can adjust parameters like pump speed, number of rollers, tube diameter, occlusion, back pressure, and fluid type, and then observe their effects in real time. Viewers, what do you think about this simulator? Any weird or funny observations? For the viewers at home, what other variables might you like to see included in this simulation for an even more comprehensive understanding? Great point. Viewers, what specific questions or topics would you like us to explore further in our upcoming live streams related to biomedical simulations and interactive tools? It's worth noting, viewers, that all of our work is eventually available on the BioniChaos.com site, so keep engaging. Are there any other specific aspects or features of this site that you would like me to discuss or highlight for you?
We've lost the co-host or the main host, whichever way you look at it. And not sure what happened there. How big is the tab? Yeah, it's 1 gigabyte. 1 gigabyte in the browser. It's not great, is it? Anyhow, there is a human in the loop. If you have any questions, go for the chat. We had these 2 robotic arms. We'll open both in the live server. So we had one generated by Claude. Yeah, there's advantages and disadvantages to both. We haven't deployed this one yet. The one with the dark background is more advanced. They both have demo modes. So it's meant to be like whatever, moving a ball around. In this case, that ball is actually indicating the grip strength, which is a bit weird, but okay. This one you can actually control the prosthetic arm, the robotic arm on the canvas itself. Yeah, obviously you don't need 2 buttons for. So that's kind of nice. The demo meant to be going through different demo actions. So meant to be 3, I think, in the code, but I don't think it's switching between them properly. Or maybe it does. So it has this one. It has a bit larger wave. Yeah, so it has this 3. It meant to indicate at the bottom which demo action is currently playing. Yeah, something is wrong. You can control the wheel mouse. You have also keyboard shortcuts.
Okay, I see an interactive prosthetic arm simulation. It seems to be exploring degrees of freedom, and there are controls for shoulder rotation, elbow flexion, wrist rotation, and grip strength. The simulation also displays the degrees of freedom as 4, range of motion as 62%, control type as Myoelectric, and response time as 120 milliseconds. Alright, focusing on control type, response time, and range of motion. The control type Myoelectric uses EMG signals, which are electrical signals from your muscles to control the arm. Response time, currently at 120 milliseconds, refers to how quickly the arm reacts to those signals. The range of motion, as a percentage of a natural arm, indicates how much the prosthetic arm can move compared to a typical human arm. These aspects are crucial because they define how intuitive, precise, and functional the prosthetic arm is. A faster response time and a greater range of motion generally translate to a more useful and natural feeling prosthetic. What aspects of myoelectric control do you find particularly interesting or limiting?
Okay, so with the myoelectric control at the moment, what's the relevance of that indication for the simulation? We cannot change it, can we? Can you elaborate on that?
So if the control type is myoelectric at the moment, what's the relevance of that indication for the simulation? Also, you mentioned we can't change it, can we? Could you tell me more about that?
Okay, the bot is hallucinating on us, the co-host. I mean, still have the co-host, but it's hallucinating. Now I was asking, why do we have the control type indication if we cannot change it? If we cannot change it.
Why we have the control type indication is to show that this particular simulation is demonstrating myoelectric control using EMG signals. This is relevant because it highlights a common method used in modern prosthetics, where muscle signals directly influence the arm's movement. It gives you
Yeah, but how is it relevant to the simulation if we cannot change it? And if it was a different control type, it would not change anything on the simulation canvas, would it?
You're right. To question that. Even if we can't change the control type within the simulation, knowing that it is myoelectric is still relevant. It sets the context for understanding the arm's capabilities and limitations. For example, myoelectric arms can offer very intuitive control, but might be affected by factors like electrode placement, muscle fatigue, or even environmental conditions, which might affect range of motion. The simulation could be designed to illustrate those impacts, even if we can't switch to a completely different control system for comparison. Got it. For those of you watching, feel free to share your thoughts and feedback on this prosthetic arm simulation. What aspects do you find most interesting, and what areas do you think could be improved? Your input is welcome. All right, looking at this new prosthetic arm simulation, I can see it focuses on joint control with sliders for shoulder yaw, elbow pitch, and wrist pitch. It also displays metrics like grip force and end effector position. A key difference from the previous simulation is the direct control over individual joint angles, instead of the more abstract grip strength or preset movements. Which simulation do you find more intuitive or engaging, and why?
Okay, there is a human in the lobby. If you have any question, go for the chat. So your comments are very important to us. Now we have with this voice model with the screen sharing, we have a almost 2 gigabytes being used in the browser. So those, like, would imagine would be all the videos uploaded to Gemini. And I guess that's the main reason why we are losing the co-host. Yeah, good memory usage for a browser tab would be around under 100 megabytes, not 2 gigabytes. Yeah, so we have these two prosthetic arms. Yeah, I wish there was a tool to just combine two of the codes. Well, in theory, the LLM should be able to do it. So I like the looks. Let's turn them into 1 and 2 because it doesn't really matter which model originally made it. We'll generate another index HTML, so we'll essentially be combining features, the best bits from each one. What we'd like. Yeah, don't get the range of motion. I like the grip force here as being controlled. The grip force. It's the second one. And then we also need to start going over the demo actions. Currently at the bottom left, below the canvas bottom left, it keeps showing mode manual DOF3. So it doesn't seem to switch between the demo actions. Well, actually it does, but then the indicator should get updated as well. Maybe in the console you can indicate which current demo action is playing. Yeah, this one is much better. Play demo. Right, no, because it's removed the other button. Still working, still doing stuff. Agent. So play demo. Okay, the demo is working. Okay, reach. We have wave, reach, a grip show. Wave, reach, grip show. Okay, and it's being indicated currently. So that's good. Yeah, the sound obviously will be some sort of annoying. So we have a wave, we have a reach. What is the grip show to know? Hey, let's give it to another model. A Claude. Let's do GPT-5 mini. Okay, so it looks much better. Keep everything as is in terms of the visualization. The speed is working okay. Okay, now in a couple of things. So first of all, when in demo mode, when the demo mode is playing and we're actually interacting with the inputs, with the parameters, we want the demo mode to actually stop. If that's not gonna break the code, can you just go ahead and adjust the code? Now also another second thing, when we on the canvas, when we actually modified the joint control position, can we actually somehow indicate which is the current joint that is being controlled, for example, by changing the color of the joint from black to something else, to red or something? Another third thing, if we can actually add the digits to the arm, and have another, so we want essentially another degree of freedom. So currently we have shoulder, elbow, wrist. We also want the open and close of the digits of grabbing objects. So for grabbing objects and things like that. Also, another additional thing, we need to improve the text at the bottom of the page. So we actually need to expand the section about the simulation, how it works, how to use, expand that section, technical parameters, mention degrees of freedom, range of motion, and also include a section of future direction, what directions, what can be improved. Main. Oh, we need a demo button as well. Demo next. Reach. Yeah, that could be made clearer. What's the current demo action? Yeah, and you can you have keyboard shortcuts. What were we doing? Okay, so we had this big prompt. Yeah, we had the older version as well, don't know. What do you think of that one? It's kinda, the looks are nice, but the functionality is much greater for this new version. It modified the code to stop the demo mode when the user interacts with the controls. Let's see if it's working. Yes, it is working. Okay, let's keep the demo mode playing. Add the same behavior for the joint sliders. Now it's adding visual feedback for the active joint. We'll modify the drawing code to highlight the active joint. Did you do it? It's nice. As for red, green will do as well. Thank you very much. Okay, we have the gripper. Drawing code visualize the gripper. Okay, it added the gripper. Very nice. The gripper could have been made larger. A gripper. Demo, wave, reach. Okay, grip show. Okay, now grip show actually makes sense. Thank you very much. The demo mode could have been cycling through the demo actions. Maybe. Okay, can you review what's on the screen real quick in 1 or 2 sentences? Make it engaging.
I see an interactive simulation of a prosthetic arm that's controlled by sliders for different joints. The arm is demonstrating a wave motion, and there are metrics displayed for grip force and end effector position.
Okay,
is there anything specific
happening,
you would like me to focus on?
What's happening now?
I see you're clicking the next button under Demo Actions, which is causing the prosthetic arm to cycle through different pre-programmed movements like reach and grip show. Would you like me to describe the specific movements of the arm in each demo?
Okay, we lost the co-host. And that's only... It's already almost 1.7 gigabyte in the browser. That's very inefficient, isn't it? Okay, so there are a couple of things. So in the demo mode, when the joints are moving, you would expect the controllers to automatically update as well. For example, when the gripper is changing in grip show demo mode, we expect the joint control for the gripper to change accordingly. So everything is in sync. Okay, another thing, we probably can get rid of the reset button. We don't really need it. So if safe to do it, if it won't break anything else in the code, go ahead and get rid of the reset button. The indication of the current demo action, instead of the below the canvas, it can be next to the next button. So pun intended. But yeah, you can improve essentially the location of the indication of what's the current demo action is. And the most obvious location for it is next to the button that is changing, that is scrolling through the actions. Now, eventually, I don't know how hard would it be to do. We would like more demo. We would like to be able to add more demo actions later. So potentially we'll have a drop down or a list, which would be good if we had a list, because then when scrolling through it, we could just indicate, which one is being selected, which is the current action that is being selected. Also, in the demo mode, we could be cycling through the demo actions somehow. Eventually, I'm not sure how difficult it will be to modify the code to do it, but we would like a demo mode where we could move a ball with the mouse, and the robot gripper would be trying to catch it, for example. So I don't know if you can just modify to the code accordingly, or just add it as a description in the text for future directions.
All right, let's get critical and engaging. One thing I notice is that the arm movements, while present, seem a bit rigid. Perhaps some smoother transitions or more realistic physics could make it more engaging. What do you think about the user interface? Are the sliders intuitive, or could they be improved for better control? That's an interesting idea. Making the gripper arms larger or bent could definitely give the arm a more robust and functional appearance. It might also make it seem more capable of handling different objects in the simulation. Changing the gripper slider changes the grip force metric. How would bending the gripper the other way affect this? Looking at the demo actions section, it only has reach and wave. Maybe adding more pre-programmed actions or poses could add another layer of fun and engagement to the simulation. What actions do you think would be the most interesting to include? Looking at the simulation, the gripper arms seem to be moving symmetrically, opening and closing in a claw-like motion when you select the Grip Show demo action. To improve this, you could consider adding more nuanced control over each individual gripper arm, or make them more flexible. Perhaps introduce a visual representation of the grip force, like a color change on the gripper depending on the force applied. From what I see, the angle of the gripper seems to be fixed relative to the wrist. This keeps the design simple, as you mentioned. If you're looking to keep things simple, maybe you could add an option to switch between different fixed angles for the gripper, rather than allowing continuous adjustment. What do you think about this idea? Of course, the Prosthetic Arm Interactive Simulation is an educational tool that allows users to explore key concepts in robotic manipulation. You can control the arm's joints using sliders and observe the effects on grip force and end effector position. There are also demo actions like reach and wave to showcase the arm's capabilities. You got it! The Prosthetic Arm Interactive Simulation and many other educational tools are available on the BioniChaos website at https://bionichaos.com. I recommend viewers visit the site and provide their feedback. What other aspects of the website would you like me to highlight? To wrap up, we discussed the Prosthetic Arm Interactive Simulation, available on the BioniChaos website. We analyzed the arm's movements, user interface, gripper design, and demo actions, brainstorming potential improvements for engagement and simplicity. We encourage viewers to explore the website and provide feedback. Is there anything else before we say goodbye?
Yeah, there's a human in the loop as well. If you have any questions, go for the chat. Otherwise, we will be finishing up.